All right. Thanks for everyone for coming. I better take off my mask. That might be a little better. Anyway, I just wanted to say I'll be running my slides a little faster so that Professor Andrews can have the bulk of the time. So without further ado, I'm going to be talking about circularity, planning for carbon reduction. As I said, I'll probably skip some of these slides because they're repeat. For instance, I think most people understanding the scope 1, 2, and 3. We had a great talk just previously that went into quite a bit of time in that. But this one, it sort of puts things into context, right? So if you're looking at a product life cycle of IT equipment, you can see from the slides that how much carbon is used to first mine, and then process, and then transport, and then actually do the component manufacturing. With all this in mind, you can see where the emissions and the waste gets generated as through the product life cycle, right? So I think most people understand that IT Renew's business is sustainability as its #1 goal. And one of the things is some of these points, right, is scopes 3 is more about upstream supply chain. 75% of carbon is tied to IT, is scope 3. So if you look back at the previous slides, you can see where a lot of that is from scope 3. And what's underscored for all of this is there's a huge opportunity for a creation of second life. And if you've seen Ali's talk on keynote, you can see that there's a tremendous opportunity here to do that. And so if we all collaborate together, and that's why we have the work streams under sustainability work streams, we can do some great things. But the key part of it is measuring what that is going to be an important goal for that. I think most people understand the circularity business model. I'm going to pass that. Kind of putting those, when we're talking about measurement, like putting these things in context. So if we've deployed a total of 24 racks, that's going to be 48 servers and then about 46,080 cores, right? So the cumulative metric ton of CO2 is going to be around 2,400 tons. So how many is that? That's the equivalent of 466 cars on the road, 17 acres preserved from deforestation. So it's not a small amount that we're saving. I had a small case of studying circularity, but I'm going to skip that. And my slides are done. So I am going to introduce Dr. Deborah Andrews from London South Bank University. There you are.
Hello, everyone.
I see you.
Yep, good. Hello, thank you very much for asking me to talk at the OCP Summit. I'm here in London. It's quite late at night. I hope you're having a really interesting and beneficial time in San Jose. Yeah, let's go for the presentation. Okay, so yeah, my name is Deborah Andrews. I'm an associate professor of design at London South Bank University, specialising in sustainable design and manufacture. And I've worked with the data center industry for about 10 years on various research projects, but I became increasingly aware that there is a big problem with e-waste and so forth through my experiences on various research projects. And in 2017, I started to put a team together to set up the Cedaci project. We applied for funding from Interreg Northwest Europe and were successful and got funding. So since the end of 2018, we've been running the Cedaci project, which is basically kickstarting a circular economy for the data center industry in Europe, although what we found is obviously applicable globally. And so I'm going to talk to you a little bit about the project now, and also about one of our key outputs, the Circular Data Center Compass, a digital tool to model and assess data center sustainability. So could we have next slide, please? So I'm sure as experts in the sector, you're all aware that now it's about 60% of the global population are connected, and that around 4.2 trillion gigabytes of data is generated and processed every year. Next slide, please. And all of this activity happens in about 7 million data centers around the world. And obviously, investment in the sector is absolutely astronomically high. And it's really remarkable. This sector is absolutely unique at the speed and size of growth. Next slide, please. Now, this speed of sectoral development and emphasis on service provision means that the sector has really evolved in a linear fashion, where we've been taking resources, making products, using them, and then disposing them. There hasn't been any time to really think about anything else other than this model of development, this type of economy. Next slide, please. And that was one of the reasons why the Cedaci project was set up. There's a real history or pattern of silo working in the sector, which obviously employs millions of incredibly talented and experts, but people do tend to work in silos based around their subsectors. So the Cedaci project, one of our unique points is that we're bringing together representatives from all the different subsectors and life cycle stages, and using whole systems or whole life thinking to tackle the problem. We really need a holistic approach to the challenge in order to accelerate the development of the circular economy. So ultimately, our project aim is to reduce waste, to present or avoid supply chain problems in order to ensure an uninterrupted and secure DC operation and service. Next slide, please. So one of the key outputs to assist development of the circular economy is the Circular Data Center Compass. And this is a free online resource. It's not live yet, but it will be live imminently. And basically, it is a product sustainability and circularity indicator. And it allows businesses to compare environmental, social, and economic impacts and materials criticality of different servers. What we want to do through the tool is to help businesses to make really informed decisions about their choice of products according to their company requirements and performance. Next slide, please. One of the really big differences between the work that we're doing on the Cedaci project and many other projects is that most of the data that we are collecting is primary source. So we are literally rolling up our sleeves and reverse engineering products to collect data. We're building inventories, improving recycling processes to enhance critical raw materials reclamation. And we're building complex life cycle assessment, life cycle costing, and social life cycle assessment models. And the data from all this research feeds into pilot projects. So we are designing and building a prototype circular service in one pilot. We are looking at second life, extending product life, and refining business models and so forth to increase that in pilot B. And then the third pilot, we are really looking at what happens to products at end of life. And I said, developing improved critical raw materials reclamation processes. And all of this data, of course, is feeding into the CDCC or Circular Data Center Compass. Next slide, please. So here we are. Eventually, this is what you'll see. you'll be able to access the compass through our project website. And once you have signed up, you can log in and so forth. And you will have a unique password, so your data will be secure, as with any other tool. Next, please. So the tool itself is going to give you as a user various options. You'll be able to compare the impact of different servers. So you can make decisions on, whether you want to refurbish or buy new, etc. You'll be able to compare the impact of different end-of-life scenarios, and I'll talk about that in a bit more detail in a minute or two. And also, if you are designing and developing new products, you'll be able to see how circular or otherwise they are using the Ecodesign evaluator tool. So, as I said, the majority of the data is based on its primary source data. We're not making models based on assumptions and secondary data. So we believe that the models are a lot more accurate than many other models that are circulating. And the other key thing is that the work relates very closely to the EU Circular Economy Action Plan. So by using the tool, industry should be really prepared to conform to the guidelines proposed there. Next, please. So the compare tool, as I said, the intention is for users to be able to assess whether they want to extend product life or to replace with new products. We have based all our models on circular footprint calculations that accounts for burdens and so forth of different resources and inputs and outputs. So this is what you'll see on screen. Sorry, I'm finding it difficult to read this because the type's very small, but okay, next slide, please. So as an end user, you'll have two boxes, which you can then swap in and out different components. So let's say you want to upgrade an existing server, you can change memory type, hard drive, etc. And then you can make a decision. So you are able to configure two servers. And next slide, please. And then once you have added used the default data from the various components, you'll see results and impacts, and you'll be able to download a PDF report, but you'll also see a snapshot. Now, what we have done is to disaggregate results, so into environmental impact, economic impact, and social impact, and then finally the criticality indicator. The reason we've done this is so that you as an end user can base your decisions of whether you're going to buy new or upgrade or whatever, based on your company's priorities. If corporate social responsibility is your key driver, then that's obviously those are the results that will guide your decision. And then the criticality indicator, that's completely new research as well. Again, if you decide that you want to reduce the critical risk of the products, that would be your driver. Next, please. And then we move on to end of life. What will happen if you decide that you want to upgrade to or replace your product with a new server? What you're going to do with your existing server? You could compare sending to landfill. Well, we put this in because as a sort of benchmark to really highlight the benefits of either extending product life through refurbishment and reuse, or recycling using current industry methods, or recycling using Cedaci recommended methods, which are, they reclaim many more critical raw materials than current recycling methods, including things like tantalum. Next, please. And again, you'll see the results disaggregated into environmental, economic and social impact and criticality. And you'll be able to compare the various sustainability categories or the impact of the various end-of-life scenarios. So we are building data sets, literally by reverse engineering products. And we will be asking for more servers in a minute or two to make our data sets more comprehensive. Next slide, please. So the third element of the tool is the Ecodesign evaluator. This is based on a lot of data from the EU Circular Economy Action Plan, which stipulates various criteria, could be to do with firmware or whether information is supplied or how long firmware, etc., will be available for example. So quite a complex array of inputs. And we have, as with the other elements of the tool, tried to simplify the interface as much as possible to make it easy and intuitive to use. So when you're designing your server, you'll be able to change particular criteria and you'll see the results live. You'll be able to assess how circular or otherwise your design proposal is. And ideally, the blue shape in this spider diagram, the most circular option would completely fill the spider. Next, please. So what are the benefits and the value of the Circular Data Center Campus? Well, I'm sure that you're all aware that we are generating an astronomical amount of e-waste every year. At the moment, it's about 50 million tons. And if we carry on acting as we are at the moment, by 2050, we'll be generating 120 million tons a year, which is obviously incredibly wasteful. At the moment, recycling infrastructure is very, very underdeveloped, and only about 20% of e-waste is formally collected and recycled, and it has an incredibly high economic value. So in servers, typically we'll find 69 elements found in the periodic table, and 7 to 10 of those elements are regarded as critical raw materials, which are basically of high economic and technical significance. Without them, the data center industry wouldn't exist. So there's obviously a really urgent need to improve recycling and reclamation of materials. But until we have that infrastructure, it's absolutely essential that we extend product life or wherever possible and technically and economically viable to meet company needs. And I should mention at this point, one thing I didn't mention previously is that our reuse and refurbishment options in the compare tool don't just consider materials use and so forth. They also consider performance and energy consumption and dispel some of the myths about older servers being less efficient than brand new products. We've incorporated the Interact tool, which was developed by one of our partners, TechBuyer. Again, that tool, the data is all based on real experiments at their company. So we really believe that the data is very, very robust all round. Next slide, please. The final sort of USP of the work that we're doing is, well, not only are we using primary source data, but our models are not just assessing carbon and carbon equivalents. We are measuring the inputs and outputs of thousands of different materials, etc., and creating really comprehensive life cycle assessment models. And we can see the difference between carbon assessment and full LCA here. The results are quite dramatically different. With carbon equivalents, if you compare the impact of the operational phase and embodied impacts, typically we see that embodied impact only accounts for something like 15 to 20% of overall life impact. When you measure thousands of inputs and outputs, that ratio changes very dramatically. And we can see that embodied impact from full LCA studies accounts for somewhere between 30 and 50% of overall life cycle impact. Now, these results are indicative, and so far we have assessed a number of servers, but we really need to make more robust, or to create more robust results by assessing more servers so we can get better, more accurate picture. Next, please. All of this, of course, is incredibly important. We really need to do something now, because based on 2018 figures, the data center industry provision is going to expand 300% in the EU by 2025 and 500% around the world by 2030 as more services like Internet of Things, etc., become ubiquitous. Next slide, please.
Dr. Andrews, we have a little less than 3 minutes.
That's it. I'm nearly done. Okay. That was my last slide, which is basically contact details. You can follow us on Twitter, on LinkedIn. Please join our network. We will be holding training sessions in December, January, February for small to medium enterprises, primarily in Europe. Training sessions about the Circular Data Center Compass, but please contact us if you would like more information. And if you have servers that you don't need and are willing to donate them to the project, then we'd be absolutely delighted to take them off your hands for you. Okay, thank you very much.
All right then. That completes the end of our talks. I hope you found them interesting. And if there's any questions, I think we have about 2 minutes left. Any questions for? Yes, go ahead.
I had a question regarding the end of life and the recycle.
I don't think your mic is active.
Hello?
Yeah.
I had a question regarding the end-of-life LCA analysis, and you had categorized it into 2 parts. One was recycle and one was landfill. Those were the in that software that you developed in order to do the software model in order to do the calculations. So I had a question regarding these 2 categorizations. And for example, if you look at the recycle, recycling is different, is done differently at different places. So for example, one circular center, what they can do is they can break the PCB board into into different components, and then recycle those individual parts of the PCB boards. Some people can just recycle it at component level, just the chips or something like that. And the carbon dioxide emissions differ based on the type of recycling that you can do, right? For example, if you cut the boards, then you're using heat to cut the board, and there is emissions associated with that. If you just recycle the whole motherboard, which is not usually how it's done, but in that case, the emissions can be reduced. So in that particular model, how do you divide it into or is there some detail in how the modeling is done?
Yeah, thank you. That's a good question. Actually, we have 4 end-of-life scenarios because in addition, well, as I said, we include landfill as a sort of benchmark. We don't recommend that at all, but unfortunately it happens. We include reuse and refurbishment as an option. So it's end of first life rather than end of total life. And then we have recycling using current methods, and those obviously include heat and chemical processing. And then the Cedaci methods, which are a mix, again, of heat and chemical processing. Now, the models that we have at the moment are based on sort of generic locations. They will details or the results would change according to geographical location where, stuff is processed. So if it's processed in a country with very high use of fossil fuels rather than renewables for energy production, then impact of recycling is going to be higher. We're trying to make the models as flexible as possible, but I think we could go on, ad infinitum if we included absolutely every single variable, and you could choose, from, I don't know, however many countries there are in that practice recycling. Every scenario is going to be slightly different. But I will say again that the recycling, current recycling methods, they don't reclaim as many critical raw materials as the Cedaci recommended method. And that we have got primary source data for that from some of our French partners who are developing the technologies. Does that make sense?
Yes, definitely.
But we're not, user and end user, you'll see that every page, if you like, or every sort of drop-down menu for each of the different stages in the tool, there is an explainer, with an explanation of how what is included and excluded, the scope of each of the life cycle stages, etc. So we won't give away the free data, all the data, but you'll understand the general context of each activity that's included in the tool.
So at the end of, I'm sorry.
We're kind of out of time, so I'm sorry. I'll have to cut it off.
Please contact us via the Cedaci website. There's an email address, and please contact us, and we can have a chat. Okay.
All right, everyone. Thank you.